Hello everyone, welcome to the Nexus QI online classes. Before you think magnetism sounds serious, but don't worry. Today's chapter is so attractive that even your attraction will stick to the end. Yes, we are starting the chapter magnetism where objects don't fall in love, but they definitely get attracted. Magnets are everywhere, from fridge door that refuse to close properly to compass that know direction better than most of us before Google Map. And no, magnetism is not a magic, even though it sometimes feel like it. In this chapter, we will understand why magnets behave the way you do, what invisible magnetic field actually look like, and why like poles don't get along just like some classmates. So sit comfortably, grab your notebook and let make your physics stick literally. Let's begin magnetism. Before starting the classes, kindly subscribe our channel. So today we are going to focus on this chapter called magnetism. What is so interesting about this chapter and why the chapter is very difficult sometimes? So there are few points. Again we are going to decode the chapter in very easy way. So there are total 6 points in this chapter. 1, 2, 3, 4, 5, 6. And we have to decode all the 6 thing into a very simple manner. But what is the core and what is the basic of all the 6 sections? Only one thing that is very basic in all the 6 sections and subsection we can say, that is the field. If we understand the field, then the chapter is very easy. So let's try to understand the field. So we have bar magnet. This is the bar magnet. This is north pole and this is south pole. But if we see, there are some hypothetical lines, and these lines are imaginary field lines from where we are getting. So these field lines are coming from north and going to south. But one thing we have to understand, line have to complete the loop. If we are able to complete the loop, then only field line will complete. So we can say that the field line will start from north and it will end into the south, outside. But if we see inside, the field line will go from south to north. But the main thing is that how many field line will come, number of field lines should be the same. Suppose we have the 5 field lines, it have to complete their loop. All the 5 field line have to complete their loops. So, but from where we come to know the direction of field lines, but this is the main things we have to understand. From where we come to know. So for that we can use the two things. Either we have to use the compass. Compass is a simple instrument having some needle, a small needle, that is north and south. And other things we can find out that if any free falling, this is imaginary concept, if we are going to keep here any north pole, the direction or the force of the north pole decide the direction. Okay, like we have the only 2 methods we can find out the directions of the field lines. These all field lines club together and form magnetic field. Okay, so this is the basic concept of the magnetic field. So what is so common in this? See, if we see the field lines, we have some properties about the field lines. We should know minimum 4 to 5 property, and on this basis only entire chapter is, we are going to complete the entire chapter. What are the property I am going to write? First, field lines should not interact with each other. 2 field lines can never interact with each other. Why? The reason is very simple. Suppose for few seconds both field lines are interacting in this point. But if we are going to keep compass here, then compass will get confused. Okay, so he can't give the exact location. So it's impossible to put 2 field line at one point. Apart from that, the larger the gap between the field line, the lesser the force. And if the field line is very nearer, force will be more. So again, it's depend on the number lines or the area or the gap between the field lines. Again, more gap, less force, less gap, more force. Now, third property. Third property is very simple again, because entire chapter is based on the field lines. So, exactly we have to understand all the 3 or 4 points. Next, always field line start from north and it will end in the south. Outside, I am talking about outside, but inside opposite. Field line will start from south and it will go to the north. Okay. Now, these are the 3 to 4 basic concept or basic characteristic of field line. If you understand entire chapter, very easy. This is how we decoded the things. Now, this all about the bar magnet, but how we come to know there is some imaginary concept of the field line, this all things. For that, there are so many activity in past we have done. What are the activity? By using the iron fillings or by using the magnetic compass, we have find out what is the field imaginary concept. And next things, if we see here, suppose I have to tell like this, suppose this is a gate and these are the field. So, everyone have to enter through this gate only. So, definitely here crowd will be more compared to this or this place. So, definitely again I told, if crowd is more of the field line, then force, this is the region in this place north at the south, means we can say in these 2 poles the force will be more. So, if we put the iron filling here, the iron filling in these 2 places attracted more compared to these 2 places. So, this is a very simple concept. Now, coming to the next concept. The second concept is again so simple. What is the second concept? We can create a magnetic field by using the electricity. How it possible? By using the electricity, how we can produce the magnetic. So, simple, this is the again this is the experiment, or we can say that it is the accidental experiment. Suppose this is the rod, and if we connect the rod with some source, battery source, so we will feel magnetic field here. What is magnetic field? We already discussed, this is imaginary line. But how we can create it, how we have created the field line in the conductor? It's very simple. Now, if we focus on this point, so we will experience the field line like this. Far we go, the effect of the field line, or we can say field line nothing, just a force. So, more or further we will go, we will experience a less force compared to this area. So, suppose the question they can ask like this, they will give some point 1, 0.2, 0.3 and 0.4 in the board, and they will ask in which point we are going to get more force. So, according to that, 1 more force compared to 2, then 3, then 4, like that they can create a questions. Okay. So, it is again very clear, in the rod connected by the battery source we can experience the field line. So, by the use of electricity we have converted this and we got these field lines. Okay. So, again we produce the magnetism by electricity. So, this is the very important concept, by using the electricity also we can produce the magnetic field. Same way, but how we can find the direction? So, suppose this is a rod conductor. Okay. So, if this conductor is connected by any battery source, okay. So, now if the direction of current is this way, this is the direction of current. So, just we have to put our thumb on this, on the path of the electric current, and we have to curl the hand. The curling, so this is the area, and the curling, so the field line. This is the, if the current direction will change, suppose from up to down, again my curling will be same, but clock and anti-clock we will see. We will get the experience of clock by and anti-clock by. How? Suppose same thing we will put here, and if inside the board if current is going, then we have to curl the field. So, our curling is just coming like the clock direction. So, this is clock by, and if the current is going this way, so this is the direction of current, our curling will be like anti-clock. Very simple. For that I am giving the trick SCAN. No need to get confused. Clock by south, anti-clock by north. Done. So, it is very simple. If you know this scan, okay, the trick will help. Again I am going to repeat the trick, clock by south and anti-clock by north, and we can use some figure also for that. Suppose we will use the cross sign. Cross sign means, and if we can use the dot sign instead of dot sign, means it is coming, then this is north and this is south. Either we can use this two trick or either we can use this scan. Okay. Now, third, again, if question will be there, what is the field line? So we can say in the current conducting rod, the field line is concentric. Okay. And if they ask entire field line about the rod from up top to down, then it will be just like cylindrical. This is cylindrical. If they will ask at particular one point, then this point is called concentric. Why? Because suppose so many circles we are getting, and each and every circle is starting from one point, that is called concentric. So it's very clear. Any rod, current conducting rod, if we pass electricity through this, we will get and we will experience a magnetic field around the rod. It's very clear. Either it can be like clock by or anti-clock by. How we can find out? So by putting the magnetic compass or by using some trick like a scan and dot and cross. Till now we have discussed about the field, and field is the only thing in this chapter. If you understand the field, entire chapter is very easy. So now we can go very fast because we understood the field. Field is an imaginary concept coming from north and going to the south. Now, if just now we have discussed about the rod and we are going to convert the rod into the ring, so no problem. And again the ring should connected with the battery source. If we are going to connect it with the battery source, again same thing. Suppose that this time direction of current is like this. So just we have to do like this. Just put the thumb along the pathway of current and just curl it. So we are getting the field like this everywhere. We can say that if we focus on the small area, we can suppose we will cut this area and cut this part. We can say this is a straight line only, and if we put the finger in this way and curl it, curling show the magnetic field. Okay, either it can be clock or anti-clock. But the question is very simple: how in this ring we can find which is the north pole and which is the south pole? Because it's very easy for the rod to find the poles, because either clock by or anti-clock. But here, how we can find out north pole and south pole? Either north pole from my side, or if we go behind the board, it can be south. But how we can decide which is north pole and which is south pole? So for that, again I am going to give some trick. The trick is very simple. Okay. So the trick is, we already draw the diagram. Just suppose this is the ring and hold we can imagine 3D. Just hold the ring like this. This is not like this. This is like this, 3D. Hold the rod like this, and we can see that if we are holding the rod like this 3D, okay, and after holding, just put your finger along the direction of current. So suppose this is the direction of current, put the thumb and curl it. Start curling, and we will see what is common in each and every curling. It's coming from inside to out. If we have to complete this, it's coming from inside to out. So like this we can experience the magnetic field, and the part where it's coming is called north pole, and the field and the part where it's going is called south pole. Again, so simple. So everything is filled. Again, we have started with the rod, we converted the same rod. We started with the rod, and suppose we convert the entire rod into the ring. Concept we will be seeing: put the finger, thumb in the direction of current and curl it. We will get the field. Same thing. Now again, if we multiple so many times, if we give the turn of this ring, this is called multiple turn, then definitely number of field will be more. If we turn it 5 times, so 5 times more we will get the field. If we turn 6 times, 10 times, the number of time we will turn, number of more magnetic field we will get. So this is called solenoid. This is the solenoid. Again, the concept is very simple. So for explaining the solenoid, I will give the small trick. Just focus here. We just told that field line will not interact with each other. It's very impossible to interact the two field line at one point. But what is happening inside the solenoid? See, suppose this is the ring, and number of ring we just increase the coiling, and let's connect it with the battery. So now just focus here. This is the field line. Suppose here we just, it look like it look like that two field lines are interacting with each other, but I just told two field line will not interact with each other. It can't interact with each other, but they are so close, it looking like they are going to interact. So field line, instead of interaction between the field line, they transform, they form the new field line. So we can say that suppose this is the solenoid, or number solenoid is nothing, just a repetition of ring, so don't worry. So if we see, and they will keep on transforming, instead of so many small field lines, they will make a big field line just like the bar magnet. If the field line is coming and if the field line is going, the coming point is called north, and where the field line is going inside, that is called south. But what is the important question here for the board? Inside the field line, inside the solenoid, the field line will be constant. So what type of question they can produce here? It's very simple. They will give some point, 0.1, 0.2, 0.3 and 0.4, and they will ask at what point, at which point the field line will, force will be more. Definitely the answer will be very simple, 1 equal to 2, because 1 and 2 both experience the same force, because the field lines are constant. And then third, and here we are going to get, this is the place we can give the 4, suppose, and here we are going to get very less force, because field lines are very far from here. So maximum they can ask this, they will give some points and they will ask at which point they are experiencing the more force and at which point they are experiencing the less force. So again, till solenoid also the major concept was field. If you understood the field and if you understand the characteristic of field, chapter is very easy. So instead of going detail about the chapter, what we have done, we have just decoded the chapter into the very simple way. If you understand the field lines and from where we are going to field line and some characteristic about the field line, chapter is done. Now last point of the chapter, how we can increase the strength of the solenoid. So we can say that by the more turning per unit area, coiling per unit area, if we increase the coiling per unit area, we will get the more field then more force. Second, if we increase the intensity of the current, again we will get the more force. Third, the third concept is the gap between the air should be less. This is not in our syllabus, but if there are less gap or less air inside the coil, we will experience the more field, and more field means more force, field means force. Now the intensity of current, so we can say that KIN, we can write kin. Okay, intensity, number of coiling, K is just a constant that decrease the gap or air should be less. This is called kin, but not in our syllabus, don't worry. And we can write the, because this is a magnetic field, initially only I have to tell, we can represent by the B. Okay, this is the vector quantity, so it's have a direction also. Okay, and the unit is Tesla. So till now we have seen how we can utilize our simple concept of field line in completing this all the chapter. Now the last concept and very important concept, suppose what will happen. So this is the current conducting wire, and in between we will put some bar magnet. So we can say that there will be two forces interacting with each other, or we can say two fields are interacting with each other. It have their own field and north and south have their own field. So see, in this place some interaction is there. If the two forces is interacting with each other, remember, if the two forces is interacting with each other, definitely, then suppose these are the two fields and they are going to interact with each other, force will produce. So definitely there will be some force, and for that left hand rule we are going to use here. So this is north, this is south, definitely some field will be there. This is a constant. We can't create a single south and north, but this is a horseshoe magnet, just imagine. And in this we are going to put some rod. How we can use this? So we have to adjust this three, and all the three fingers should be at 90 degree. It should not like this, neither like this, all 90 degree. There should be all the angle in between 90 degree. First we have to manage only these two. This is for force. First F, B, I. F, B, I. F means force that we are going to find out. B, magnetic field. I, current. Suppose this is the direction of current. So first only try to manage these two fingers. So this is the direction of just curve. This is the direction of field. So keep the finger like this, and this is the direction of current, and open the finger. Definitely the force the rod experiencing inside the board. Again the force the rod is experiencing inside the board. From where we are going to get this all left hand rule? So we actually inside the rule started with the Newton's law, but we are not going to show depth from where we are going to get these rules, but use the trick, use the finger for this direction of the magnetic field and this finger for the current. And again we are going to, if we change the question, suppose the direction of current like this, only focus on this finger, let it be here and just turn, because this is the direction of current, and open this. In this time the rod is going to get experience force they are going to experience outside the board. Okay. So this was the major concept, and again this concept was also based on the field line, and this is just an interaction of field line, and because there are two things is going to interact, the rod current carrying conductor and the field that we are getting from the north pole and south pole, that should be the constant, and actually we can't create the unit north and south, so this may be the part of the horseshoe magnet. Okay. Now, so this all was the major concept, and how we have decoded the chapter. We have from beginning to the end we have used only the concept of field lines. So let them ask any question. If our field line and this concept of field line is clear, the chapter is over. Okay everyone, that's it for the today's session on magnetism. If your brain feels slightly attracted to confusion, don't worry, it's normal. Just revise today's concept one more and everything will align perfectly, unlike poles. Remember, pause the video and revise, practice diagram, magnet love diagrams, and don't repel physics, attract marks instead. In the next class, we will continue more depth about the chapter. Till then, keep studying, keep smiling, don't try to sticking magnets to your phone, just trust me. Thank you for watching Nexus KY online classes. See you in the next session. Kindly subscribe our channel and like the video.